Welcome to the deep dive. We're here to cut through the clutter and give you the insights you really need. Today, we're diving into something pretty crucial, maybe a bit challenging too. It's navigating the interview process for statistical programmers. Foundational stuff in, our data-heavy world. We've got a great source for this, a really comprehensive guide on the top interview questions. So our mission today, it's not just what employers ask, it's figuring out the why. What are they actually looking for? Beyond the technical skills, the problem solving, the soft skills, all that, think of this as your shortcut, your inside track to understanding what a good evaluation looks like for these roles. Ready to get into it? All right. So when we talk about really succeeding as a statistical programmer, it seems pretty clear employers want this mix, right? Technical skill, but also that critical thinking piece. It's like you're building a case for yourself during the interview, step by step. Let's start right at the base. The programming tools. Our source starts with a pretty direct question. What programming languages are you proficient in? What's the thinking behind this one? What are they really looking for? Besides just a list, why is being versatile so key now?
Right. It's less about just naming languages and more about showing you get the whole picture, the ecosystem. So a strong candidate. They absolutely need R, Python, SAS, SQL. That's kind of the baseline now. But more and more, you see interviewers checking for comfort with other languages too, maybe Java or C++. Why? Because it shows you can adapt. It signals flexibility.
Adaptability, okay.
Exactly. Don't just think of it as knowing lots of tools. Think about showing you understand how they fit together, how they work in a real data pipeline. Like Python's great for scaling up machine learning, right? But R still holds its own for really deep statistical work, showing you get those differences and that you can make them work together. That's what they want to see.
Okay, so it's strategic knowledge, not just ticking boxes. Makes sense. Tools are one thing, but what you do with them is another. How do we get from just knowing the code to actually, telling a story with the statistics? When they ask something like, can you explain the statistical method you have used in the past? What kind of methods are they hoping you'll discuss?
Yeah, this is your chance to show you've moved past the textbook definitions. You've actually applied this stuff. So obviously you want to talk about things like linear regression, maybe logistic regression, and or time series analysis. Those are common. But what really makes an answer stand out in an interview is showing you understand the nuances, the details.
Nuances like what? Specifically?
Well, take linear regression. They might probe about the assumptions. Do you know them? How do you check them? What do you do if they're violated? Or for logistic regression, maybe it's about interpreting probabilities correctly or handling tricky things like imbalanced data. Our source actually highlights survival analysis as a really good example.
Survival analysis.
Yeah, explaining how you use it to study, say, the time until something happens, like a patient recovers or maybe a piece of equipment fails. That immediately shows practical, real-world application. It proves you can use complex stats to solve actual problems. Ah, okay. So moving beyond the what to the how and why. That practical angle is key. And once you are building these models, quality is obviously huge. It's not just about getting an answer. It has to be the right one. So the next logical question is, how do you ensure the quality of your statistical models?
Right, and ensuring quality. It actually starts way before you even type model DES-LM or whatever. Things like cross-validation are vital, of course. You need to make sure your model works on new data, not just the stuff it learned from.
Yeah.
That's critical.
Standard practice.
Exactly. But the real insight from the source here is about having a proactive mindset. It really emphasizes checking the data first, like really checking it for outliers, weird anomalies, inconsistencies before you build the model.
The garbage in, garbage out principle.
Precisely. It shows you get that good models are built on good data. It shows attention detail. It shows you're thinking like a data steward, not just a coder. That makes total sense. Data integrity first. Okay, let's connect that to the real world. When an interviewer asks maybe something like, can you explain a project you have worked on as a statistical programmer? How do you tackle that? How do you really make your experience shine?
This is really your moment to link the theory, the methods, directly to business value or scientific value, depending on the role. A strong answer, kind of drawing from what our source suggests, might be walking them through a project. Say, developing a predictive model for customer churn.
Okay, classic example.
Right. And you detail the techniques you use, maybe logistic regression or decision trees, maybe random forests. You'd explain why you chose them. But here's the key thing interviewers listen for. It's not just the tech specs, it's the impact.
The results.
Exactly. So you emphasize how that model got plugged into the company's system, maybe their database, for real-time predictions, how it allowed them to step in proactively to maybe keep customers from leaving, That shows you don't just write code, you deliver solutions that actually make a difference.
That's a great way to frame it, showing the whole cycle from the data right through to the business outcome. Very powerful. But let's be real, data is messy, isn't it? It's rarely perfect. A
No.
super common headache is missing data. So when that question comes up, how do you handle missing data in your analyses? What's a good approach?
Yeah, missing data is unavoidable sometimes, and how you handle it says a lot. A good statistical programmer shows they're thoughtful about it, not just applying some default fix. Our sources mention different techniques, right? Mean imputation, multiple imputation, sometimes just deleting the data with missing values.
So you just pick one.
Well, no, that's the point. The choice isn't random. It really depends on why the data is missing. Is it missing completely at random, or is there some pattern to it? Because
Yeah.
that decision, it massively affects how reliable your results are.
Right, the potential bias.
Exactly. Interviewers will often dig into your reasoning here. They want to see your critical thinking. Do you understand the trade-offs of the method you chose? Do you get the potential biases involved?
Okay, so it's about demonstrating careful consideration, not just a technical fix. Got it. This whole field, data science, stat programming moves so fast, doesn't it? Things are always changing. So learning can't stop after you get the job. Continuous learning must be massive. How do you show an interviewer that you're committed to keeping your skills sharp? When they ask, how do you keep your statistical programming skills current?
Oh, absolutely non-negotiable. The pace is just relentless. And it's not just what you learn, but how you show you're learning it. So yeah, things like reading research papers, going to conferences, that's important for staying up to date with new developments.
The standard professional development stuff.
Right. But what often makes a candidate really stand out is showing initiative beyond that. Are you active in online communities? Maybe contributing to open source projects? Are you constantly trying out new techniques on your own projects just because you're curious? That shows real passion.
That genuine curiosity.
Yes, it demonstrates a proactive drive for growth. And in a field that changes this quickly, that's incredibly valuable to employers.
That makes a lot of sense. That proactive learning is crucial. And being adaptable, keeping those skills fresh, it probably opens up different career paths too, right? It's not just about being a statistical programmer with that exact title. What kind of other roles does this skill set prepare someone for?
That's a really great point. These skills are incredibly versatile. Sometimes people overlook just how broad the opportunities are. The core things we've talked about, programming, stats, quality control, communication, they open doors to a lot of different roles. Think about titles like analytical statistician, applied scientist, biometrician, even data analytics specialist or environmental statistician.
Wow, quite a range.
It really is. It just shows that these foundational statistical programming skills, they're needed everywhere, across so many industries. It means you can potentially pivot your career in some really interesting directions later on. And, for anyone actually in this process navigating it, it's worth knowing there are tools out there too. Things like an interview coach service or maybe an offer analyzer resources designed to help you manage this competitive field.
Good point. Extra support can make a difference. Well, this has been a really thorough deep dive, hasn't it? We've gone from the essential languages and methods right through to ensuring quality, handling imperfect data, and that crucial need for continuous learning. It seems crystal clear that nailing these interviews isn't just about technical chops. It's about demonstrating how you think, how you solve problems, understanding the real-world context, and showing that you're committed to growing. So, for everyone listening, what does this all boil down to for you? Thinking about how fast data science and tech are evolving, what's the next thing? What's that uncharted territory beyond what we've discussed today that statistical programmers might need to explore to really stay ahead of the curve? What's the next frontier they absolutely have to master? Something to think about.